Welcome. This video is going to talk about the structure of an atom, specifically what an atom looks like physically and the parts or subatomic particles found within an atom. So the nucleus contains all the atoms' positive charge and virtually all of its mass. It's very dense but tiny, and it's in the center of the atom. When you hear nucleus, you probably have heard of that with cell structure. And we generally think of a nucleus as being in the center of something, and that's the same thing with an atom. It's this tiny, dense space with all the atoms' charge and practically all of its mass down in the center of the atom. And then the atom's diameter is ginormous compared to the nucleus. It's estimated to be 10,000 times the width of its nucleus, which means there's a ton of empty space around this nucleus. And in that empty space is where the electrons hang out. They just move willy-nilly or, move pretty randomly, although not totally randomly, out in that space. And that's called the electron cloud. So there's really two areas where the three subatomic particles are found. There's the tiny, dense nucleus in the center, and then this ginormous electron cloud that is mostly empty space. So the subatomic particles are the proton, the neutron, and the electron. And the negatively charged electrons were the first piece of the atom that scientists figured out, or the first subatomic particle. Eventually we learned that electrons are practically weightless and have a negative charge. And if you remember, it's this incredibly small fraction of a coulomb or volt that they have on them. But we just say -1. And we now know that electrons are held to the atom by the attraction to the positive nucleus found in the center of the atom. So overall, atoms are neutral because there's an equal number of protons and electrons in an atom. So how did scientists figure out that there was also protons and neutrons after discovering the electron? Well, Rutherford's gold foil experiment showed there is a nucleus, but it took a while longer to figure out that there were two different particles in that nucleus, one with a positive charge and one with no charge. By 1920, Rutherford had discovered the subatomic particle with the charge equal and opposite to that of an electron, and he had found that it was fairly massive or heavy, and we call that the proton. And again, the actual charge on a proton is very, very small when we measure it in volts or coulombs, but compared to an electron, it's the same amount of charge, but with the opposite charge on it. So we just say +1 for a proton, -1 for an electron. By 1932, Chadwick, who worked with Rutherford, had discovered the third subatomic particle, the neutron. And it's called the neutron because they're neutral. They have no charge. But they are about the same mass as a proton, and they're also found in the nucleus. So it's now believed that neutrons basically help hold all that positive charge packed tightly together into a small space. Because if you try and put a lot of positively charged things next to each other, they're going to repel or push back. So by putting some neutral things in between, that allows you to pack those protons even tighter. So neutrons just basically give more mass or some insulation to the atom. So then it wasn't a big surprise when Thompson discovered that two different atoms of neon had different masses, but they were both neon atoms. So he knew each atom must have equal number of protons or electrons, or they wouldn't be neon. And if you look at your periodic table, neon is number 10, so any atom with 10 protons is going to be neon. And because it was an atom or neutral, he knew it also had 10 electrons. So if they had different weights, the only thing that could be different would be the neutrons. So scientists have now found that virtually all the elements, in fact 66 of the 92 elements, have at least one isotope, or we say two isotopes total, two versions of that atom with different weights. And the protons and electrons are equal, but the neutrons are different. So there's a slightly heavier and slightly lighter version of 66 of the 92 elements. And in fact, xenon actually has 10 different isotopes.